So, welcome to the third lecture on the first unit of Foundations of Data Science. This is actually speaking something more advanced. These concepts will lay foundations to data science algorithms. Okay, so far we have seen working with data. Now, in the first class, I gave you an introduction to what is meant by algorithms. Here, we'll see some, real-time examples or real-time algorithms which are used for data science applications. The same algorithms are developed into machine learning algorithms, deep learning algorithms, and so on. So we'll see what are the basic algorithms or what are the basic steps that is being followed in data science preparation. So this is the overview of today's lecture. So we'll begin with algorithms. We'll begin with what is meant by supervised algorithms, unsupervised, distinction between supervised, unsupervised, and so on, and what is meant by association. So the first type of unsupervised algorithms that we are going to study will be clustering. What is meant by clustering? Definition: in which all real-time area domains where we can apply clustering algorithms. The next, the most important, most advanced, and one of the basic algorithms called as decision tree. Supervised algorithms, its definition, how to construct a decision tree, what is the structure, and with an example, I'll give you a detailed example about how we are going to really use decision trees to arrive at certain conclusions. Okay. In the previous lectures, I gave you an introduction to what is meant by hypothesis. So how we are going to come into a conclusion whether a hypothesis is true or false, whether it is possible or whether it is negated. Naive-Bayes algorithms, why probability is very important. I'll teach you Naive-Bayes with an example of email spam filtering. Okay. Then there is an algorithm called as a priori. We'll do some analysis on that. We'll not be going much in depth about this. And then it's time to discuss about certain review questions and some discussions. So these are the three major types of classification of algorithms. Okay, please make notes. These are the probable questions that you might face in your examinations. Supervised learning, unsupervised learning, and the association rule. Supervised learning contains labeled data. Only with the support of labeled data we can construct decision trees. We can work on naive-Bayes type of algorithms. We have unsupervised learning where the data does not have any label, or the data that we have received is not going to classify into any type of names or come under some kind of headings. When I mean labeled data, it means that the output y is known and is something classified into a definite set of values or terms or whatever it is. In case of unsupervised learning, Okay, an example you can take about, say, for example, handwriting recognition and so on. So another type, generally we can call it as association, rule mining or something like that. And this is a recently developed kind of algorithms where you don't need to have too much of emphasis. So coming back to the previous ideas, whichever I've informed, I told you, which we have discussed in the previous sessions, what is the best for what? There is nothing like that. That means that you don't have any kind of standard algorithms for standard problems. Every problem can be approached with the support and help of multiple algorithms. You don't need to expect a single solution, right? That means that you cannot reach your destination in a single bus. You need to take multiple buses. Okay, that is what is meant by this free lunch theorem, or a single algorithms for every problem. That means that every data science problem should be approached in different verticals, and we have to use our, what do you say, our common sense, our intelligence to arrive into a conclusion of which can be best for which. That does not always work out also. You need to try different options. All these things, what we'll do is that I'll be giving you a case study, a real-time project and so on. You can do all these things with the help of your real-time project so that you can really understand what is this no free lunch theorem, something which is being emphasized or which is being told to you more than once. Okay, so this you will be able to really understand only when you do some kind of projects. So coming into the first type of unsupervised algorithm, we'll take up what is meant by clustering. Clustering is a fundamental supervised learning method used to partition a set of unlabeled objects into meaningful groups or clusters. Clustering is a fundamental unsupervised learning method used to partition a set of unlabeled objects into meaningful groups or clusters. The objective is to ensure that data points within the same cluster are highly similar to each other while remaining significantly different from objects in other clusters. Customer segmentation, for example, high volume purchasers, occasional purchasers, data exploration and pattern discovery, anomaly detection. So what is meant by clustering? I'll just try to explain to you in a simple terms. You imagine that you own a shop. You have some people coming to your shop every day. There might be some regular customers. There might be some customers who come once in a while. There may be new customers which are coming every day. I mean, new customers coming every day but for the first time into your shop. So you can classify these kind of customers into the ones who is having really high potential to buy so many things. People who just come for window shopping. Window shopping means coming and going through all the shop but buying nothing. Okay, it's called as window shopping. There might be people who wanted to buy something for a very less price. There might be people who buy too much of things. So we classify them into different categories. I can classify my students into good performers who are very attentive, who do good, who do the assignments in time, who do all the classwork and homework in time. They are all good performers. I might have some kind of average performers who require some kind of coaching or some kind of extra energy from the teacher side to make him do things. Once I give him some kind of training or some kind of support, he might perform much better. And I might have a set of low performers who I can do nothing with. I try my level best to teach you. I try my level best to bring you onto the track, but still you don't come. So I'll be having three categories of. So I'm clustering them. I'm making them into clusters. I'm making them into segments. Okay, that is meant by clustering algorithms. So what we do is that we take each data point. Data point means it will have two values, x and y. X can be the input and y can be the output. I mark them in the graph, and all the closer points in the graph can be considered to be a single cluster. This phenomenon is called as clustering. So some examples of clustering algorithms: Centroid-based, K-means algorithm. See, you can see that all the blue forms one cluster, all the red forms another cluster, all the green forms another cluster. Sorry, another cluster. So here what we are doing is that we are taking a data point, we are finding out whether this point is very close to blue, red or green, and based upon the position of this data point, we cluster them into a particular category, or we put them into a particular cluster. For that, whenever I say that something is close to something, I need to have some metrics, right? I need to know how close it is. Suppose there is a point here. Okay, there is a point very close to blue. How close to blue? Can't it be within the green category? So we need to have some kind of measurement of distance of a single point from a cluster. Okay, that's called as centroid. The central part is called as centroid. So we have a type of algorithm called as K-means clustering, where we find the distance. This distance is calculated as either as Euclidean distance or as Manhattan distance. And then we do this clustering. Euclidean distance means how you do it in your two-dimensional coordinate geometry. The distance between 2 points is calculated as x1 minus x1 square minus x2, x1 minus x2 the whole square root of x1 minus x2 the whole square. Right? Manhattan distance, we take the modulus. But that formula is not now very important. How we are going to calculate the distance is not very important for us now. I'll explain to that in detail as we go on in the coming lectures. Okay. So now you need to simply understand that we calculate distance in some way or the other and put the closest one to the closest cluster. Okay. So we have a tree-like structure called as dendrograms. Dendrograms are very interesting graphical notations where you can find the distance between two data points. Okay. So clustering means bringing together all data points which is close to each other. Okay, whenever I say close to each other means you need to know that there is a distance, right? So we calculate the distance using some different methods like Euclidean and Manhattan, which I will be explaining to you in detail in the future lectures. Okay, decision tree, the supervising algorithm. It's a very important algorithm. Decision tree, I cannot go in depth about how we can create decision tree and so on. I'll give you the basic definition and fundamental understanding of what is meant by a decision tree and how decision trees are used for finding out, for coming into a prediction or for coming into a conclusion about what could be the output of an unknown variable. Okay. So a decision tree is a highly intuitive supervised learning model used both for classification and regression. So we have already discussed what is classification. We have already discussed what is regression. Classification means categorical values. We don't have numerical values. I told you now we have finite number of groups, yes or no, and so on. So that is category, male, female, it's a category, yes or no, that's a category, and so on. Regression means the values, the numbers, temperatures, and so on, numerical values, which keeps changing based upon the time. Okay. So the model is represented as a flow chart like structure where each internal node denotes a test on a specific feature and each leaf node represents the final decision or prediction. So the working of decision tree now we will be seeing in depth as we go on. Decision tree is a very important type of algorithm. We need to emphasize too much on this. It works by splitting the data set into subsets based upon what we call it as features or attribute values. And then, say last time I told you, no, we have discussed an example of whether you need to go to watch a movie or not. Okay. So first condition, whether you are sick, yes or no. You create two leaves, okay, two branches. One side yes, one side no. And similarly, we keep creating branches and nodes, and we finally come into a conclusion based on certain mathematical indices, which is going to determine what our decision is. That's why this is called as decision tree algorithms. Here we'll be using certain kind of indices, metrics like Gini index, information gain, entropy, etc. The details of which may not be required right now. We need that. We'll be studying that in detail as we go on, as we come across various real-time examples, which I'll be explaining to you step by step as we go on. Okay. So now shall I proceed to the next slide? Is there anybody who did not understand what is meant by a decision tree? Or is there anybody who wants me to repeat what is meant by a decision tree? You don't need to hesitate to ask me. I'll keep repeating a number of times. So we have, say, for example, I've taken an example here of decision tree. I told you now, categorical, yes or no. So now here, what we are going to do is we are going to give a definite set of values. whether we need to approve a person's loan or not. You are applying to a bank for a loan, and we need to see, we are going to use decision tree algorithm to check whether the bank loan can be approved or not. So we start with a root node, whether what is the income level, then the next, whether we have, it's for education or not, what is his education qualification, whether he is capable of repaying the loan or not. Second, we have something called a CIBIL score. How many of you know what is a CIBIL score? CIBIL score. Have you heard of this? What do you understand by CIBIL score? CIBIL score is going to determine to the level at which you have repaid the loans that you have previously taken, your history of repayment. The more loan you take and the more you repay, your CIBIL score increases. You take loans and you don't repay, your CIBIL score decreases. You repay in time, it increases. So based upon your CIBIL score, you can create another branch in the decision tree to finalize whether the new applicant, the applicant can repay or not, or whether the loan for this particular applicant can be approved or not. We can use a simple if-then statements and come into a conclusion whether the loan can be approved or not. Say, for example, if the income is greater than 50K, $50K, and the credit score is 700, go apply. Your loan is approved. Right? This is a simple example. Okay, maybe I'm giving you the random rough values. In real time, you can understand that this is more complex, interesting, and what do you say, very fundamental and easy way of implementing an algorithm. The next important type of algorithm, what we are going to study, is called as naive-Bayes algorithms, for which you need to understand naive-Bayes theorem, Bayes theorem, Bayes theorem of probability, is called as conditional probability, which updates the belief in an outcome as a new evidence is provided. So this is conditional probability. P of A bar B means that probability of occurrence of A given that B has already occurred. Okay. P of A bar B means probability of occurrence of B given that, probability of occurrence of A given that B has already occurred is nothing but P of B given A into P of A by P of B. We call this as naive because it assumes feature conditional independence. The value of one feature is unrelated to any other feature given in the class labels. Do you know what is meant by disjoint sets? So we'll study what is naive-Bayes algorithm as we go on in depth. How it works. Okay. I'll give you some exercises to find out some basic probability questions for you to solve out. I'll give it to you in your Google Classrooms. I want you to solve these probability problems. So it is very easy to calculate, okay, probability of occurrence of an event given that another event has already occurred. That event is called as B and this one is A. So P of A given B is equal to P of B given A into P of A by P of B. An example what we use is that for spam detection, the probability of an email being spam is calculated based on the independent occurrence of specific words like free or win. Actually, if an email contains a word free or win, we are trying to calculate whether the probability that this particular email can be a spam or not. For that, what we do is that probability of being spam given that you have free and win. This is proportional to probability of an email containing free in its text given that the email is spam. That means you already know that a previous email is spam into P of given that the email is spam and it contains win into the probability of an email being spam. Okay, as I told you, most of the data science algorithms really work upon a history of data. So what we do is that we collect a set of spam emails. We check how many of them have free in it. We check how many of them has win in it. We'll calculate the total probability of occurrence. And then we come into a conclusion whether that particular email is a spam or not. How many of you have not understood this concept? You can please raise your hands, or you want me to repeat, I'll do it. I'll give you more examples and case studies for you to understand. I presume that you have not really got this concept. I'll repeat it once again, or I'll give you more examples, and with the help of case studies, I'll try to explain things in a slightly more comfortable manner. The final and the last type of algorithms, the a priori algorithm, where we are going to use rule mining aimed at discovering relationships between items in large transaction data set. A very important famous application is market basket analysis. See, I believe all of you have used this Amazon or Zepto, such kind of app, right? All of you. So whenever you log in, you see that the recently purchased items, the items which you have bought recently, right? This means that that algorithm presumes that the items that you have bought recently have more probability of being bought again. That's the reason these things. Last time you have bought a watch from Amazon, next time that same brand, same watch will be shown to you, actually prompting you to buy that once again. Okay, it is creating a temptation inside you to buy once again. This works basically on a priori algorithm. That means that it is going to keep a basket of frequently brought items together so that you can easily find out or easily predict what is the next thing that you are going to buy next time you log in. Similarly, You might have searched for something which you have not really got. Next time when you go into that, say for example, you search for a mobile phone with a particular specification and you didn't get that. The next time you log in, you get the similar products there, right? In Amazon, you can find that below after you have seen your this thing, you can say it's products similar to the what we have purchased or similar ones, so that you in the last row come out. Come here. So this is a priori. This is a priori algorithm. Understood, all of you? So in a set of, in data set, what we do is that we classify the products or classify the values which are more likely to occur in the from a set of baskets. So here I'm just detailing the way in which this algorithm works. So what we do is that first we identify the frequent item sets, generate and test the candidates of increasing size, prune, cut down the item sets that do not meet the minimum support threshold. Then based on the interest measures, we make out strong associations. This is particularly very much attractive for food items and all those things. Tomatoes, Swiggy and all those things, you know. You have purchased some food items, you liked it, you are prompted or you're tempted to purchase the same set of items again and again because you enjoyed the taste. So this algorithm works based upon that principle. Okay, frequency of occurrence. So we have this probability of A given that B has already occurred. Probability of you purchasing something which something where you have already purchased something, right? That you are comparing two items. And if the probability is higher, you purchase. Okay. So this is some examples. What is meant by so now what we are going to do is that we are going to answer some examination questions and answers which might appear for your exams. Okay. What is meant by a feature in a data set? Explain with an example. What is meant by feature in a data set? Explain with example. Why you are not making notes? I don't understand. As I keep speaking, please make your own kind of handouts which you need to study for your exams. So a feature is a particular property or an attribute in a data set that captures the specific characteristics of a record, say age, gender, grade or marks. Okay. We have very important properties where we do feature extraction, feature selection and so on, which might be required for your next level of studies. Basically, what do you understand by a feature? Suppose you have a data set of t-shirts. A feature can be size like L, S, M, double XL, triple XL, and so on, right? Same way, for a student data set or student information, features can be age, gender, grade, etc. For prediction of house, square feet, age, construction of year of construction, location, a property that is here may not be as costly as the one in the city, right? So these are all features. Features, location is a feature, and so on. For t-shirts, I gave you an example. XL size, one feature. Color, another feature. All red colored, all white color, all black t-shirts. So these are all called as features. That is a property or an attribute. So in future, whenever I use feature, I believe that you can easily understand what is that, right? All features may not be relevant. Okay. Next important question, what is the purpose of exploratory data analysis? What is meant by EDA and what is its importance? See, the word itself gives you a big clue about what is EDA. EDA, exploring something. You are exploring the data. Exploratory data analysis. You are getting in deep about the data. The amount of information that you have is being explored. So every data set may have a set of so many features. And when we understand the statistics or the numerics behind the data, we have an analytical study. It's actually a discipline. Exploratory data analysis. The purpose or the objectives of EDA, first thing is that discover the patterns in data. You own a shop, t-shirt shop, right? You have people buying t-shirts. So you should have an idea about what is the number of t-shirts that should be there in your shop, right? You have too much XL or something, too much big shirts. You have only very few customers for that. But the normal size like XL or M or something might have more probability of being sold. So what you need to do is that you need to purchase and you need to keep a stock of more such kind of t-shirts. So all these things are something that you're going to explore within the data set, and so you discover certain patterns in the data. Second thing is that you spot anomalies. That is the differences. Outliners, we have seen what is outliners in the last time. We are able to understand outliners. For example, I am a teacher. I wanted to teach you certain subjects. I need to understand how many students will be able to grasp something that is very difficult. If every student is able to grasp, then it is easy. Majority is not able to grasp, I'll have to take my classes according to that. Am I right? So I have to change the way in which I am taking class so that it is beneficial for every student sitting inside the class. This is where I'm going to explore that particular data and come out with certain conclusions. We have some assumptions. Maybe I assume that the majority of my students sitting in this class are average students. But when I test, I come to understand that majority of my students are really bright and brilliant students. So what happens is that my underlying assumption is being proved wrong, right? So we can test our assumptions. That's the reason why we do EDA. We explore the data. We go in depth with data. I'm conducting one test for you all. And I come into a conclusion that most of you have scored much better than what is being expected by me. So the wrong thing is that I have expected. I have expected an average answer. But what I got something different. So what I can do, next time I can teach you something more difficult. I can give you more interesting concepts. So this is one assumptions. And I told you how we are going to make up hypothesis. So we do EDA to formulate hypothesis. The statement that majority of my students are average is a hypothesis. It's proved wrong, converted into majority of my students are bright and brilliant. Right? Okay, this is the purpose of EDA. Name two challenges faced in conventional data analytics systems. One is the amount of data, volume. Huge amount of data is there. So what we find it very difficult to handle huge amount of data, big data. I told you about the number of species, number of trees and plants, species, all these things are huge amount of data. You don't know, we have lakhs and millions of data. If you need to search all these things, it's very difficult. Imagine how a Google server could search and find out your email ID once you give it. It's a huge task, right? It has to go through millions of information. So what we do, we categorize, classify it, and do it. So this is one of the challenges that we have. Another one is high dimensionality. I told you the number of features can be high. Unique attributes can be high. So it is very difficult for us to come into a proper method. Apart from this, data silos. Data is isolated in different departments. We have data centers at different parts, right? Suppose you are searching for you are asking your system to log into your Gmail account, what it does? It goes to the server, right? And searches for all the accounts. Imagine how long it will take for us to search all these things. Do we need a high-end processor, right? Suppose your email ID starts with T. The Google system classifies all the email systems starting with T in a separate area, and that can be used for, that is called as this isolated different departments in each department, and then go and search in that particular department, so that the entire search time is being reduced to a great extent, and so that your system works in a much better fashion. Okay, unstructured data. You know that you have racks in your house, right? You have cupboards. In the cupboards, you have racks where you keep your dress. You know where you have kept your shirts, you have know where you kept your pants, where you have kept your home dresses, and so on. So it is, once it is segregated and housed, you can easily pick up whatever is required to you in a very simple manner. But imagine all these things are clubbed up, mixed up, and kept like it is always there in your homes. Very difficult to search and get, right? So that's a problem with unstructured data. You have all the clothes mixed up and put together in a big basket, and you need to search one dress. It takes a lot of time. But if it is segregated and kept, you know where to search. Suppose usually we have problems. Most of the boys might have problems in searching for their socks. It's a very common thing, right? Morning you get up and you start searching whole house for a pair of socks. The reason is because we keep it unstructured. Generally, it happens. Basically, and by nature, by psychology, girls are more structured. They keep things more in an orderly fashion. Not always, okay? There are exceptions in both cases. Some boys are also very structured, but in general, I feel the majority of people are like that. So 90% of the boys always keep their things unstructured, and 90% of the girls keep it structured. That's what's my assumption. Maybe I don't know how far things are changing now. Okay, so that's a problem with unstructured data. Batch processing and real-time analysis, latency issues, scalability. Scalability means making these values or making the data set in such a way that it is going to be suitable to our application. Okay, you want to make, for example, a Google map. You need to scale all the dimensions into a very small way in such a way that it is very easily accessible. Right? Scalability is a challenge that we face in data analytics systems. So these are some questions for your exams. Discuss the following data science algorithms. What is clustering, decision tree, naive Bayes, a priori. Now why I've put this slide is because I wish some of you give me answers about all these things. This is more a question answer time. Can anybody tell me what did you really understand by clustering? What is clustering? Each algorithm is explained with the following topic. See, I'm giving you hints in the way you need to write your answers in your exams. How this clustering algorithm learns, how decision trees learn, how naive Bayes learns, how a priori learns. You don't need to worry about the real working principle behind each of these algorithms because we do not have that amount of scope in your syllabus for us to go in depth about each of these algorithms. But you need to understand the skeleton and the outline of each of these algorithms. Right? You don't need to understand in depth. That's not possible within the scope of our syllabus. Okay? But you can do the basic understanding of all these things. So when you write the answers, you should keep in mind that you need to write the type of learning, the definition, what is a key feature, and give an example application for this. So that there is no way that a teacher can reduce marks in your exams. So these are the points that you need to write in your exams. So type of learning is unsupervised, how you define clustering, what is the key points that you need to keep in mind. These are the types and an example. This is the way you need to write in your exam so that you score full marks for a particular question. Right? Clustering. If you are asked to explain clustering, you need to write it in this way. Similarly, decision tree is a type of unsupervised algorithms. Flowchart like is going to create a tree, and there is another interesting algorithm called as random forest, which is made up of multiple decision trees. Now this course is named as Foundations of Data Science, where we'll be seeing only the foundation. Based upon this foundation, you need to build a big building. So you need to understand that. So what I mean to say is that only if you have understood decision trees, you can work on random forests. Okay. So I want you all to make notes while I'm talking. What are the things that you need to write in an exam? If there's a question asked on decision trees, The type of algorithm, its definition, important things, advantages, and an example. Naive Bayes definition, the Bayes theorem. Naive Bayes is usually a supervised learning. It's called a supervised because you have a label in it, first thing. Second thing is that you are given the probability of occurrence of an event. I told you about spam and email, right? Yes, you remember to classifying whether an email is spam or not. So you need to have a set of label data. You need to have a set of data, emails, which are already marked as spam. That is what is meant by labeling. All of you in this class, do you understand what is meant by labeling? An email, if it is already named as spam, it is labeled. An email that is already named as not spam, it is labeled as not spam. So you need to have a labeled data. Only when you have a labeled data, you can create supervised algorithms. Right? Understood, all of you? Any doubts regarding this? Any doubts, please ask me. If you find it difficult to ask in English, you can talk to me in any language you like. Understood, all of you? That's what is supervised algorithm, and that's why we need to use naive-Bayes supervised a priori. It's called as association rule mining, and so it's a kind of, in a way, it is also a kind of supervised learning only. You have labels for each. The example is market basket analysis based upon the previous actions. Okay. So I hope that if a 16 mark or a big question comes in your exams, you will be able to do it in a much better way. Another question, next one. Explain the techniques involved in data preparation and mention the importance of data cleaning and integration with some kind of examples. Provide examples. So what is data preparation or data wrangling? The process of transforming raw, messy data into clean, organized format for analysis is called as data preparation or data wrangling. The techniques involved in data preparation is first thing is that missing values. Okay. You need to fill in the missing values. You need to find out whether a data point is an outliner or not. Then you standardize the data with the help of z-score. You determine the outliner also with the help of z-score only. Data standardization, you have two methods. One is called as z-score and the other one is called as max-min, right? Which we have discussed in the previous classes. Importance of data cleaning. Garbage in is equal to garbage out. Accepting the not required or confusing data, removing it out. Okay. See, every machine learning model or prediction, everything works only upon the quality of data you feed in. Like our human brain also, right? You give good things to your brain, you get good things out. You give bad things to your brain, you get bad things out. You take in good things from your friends, you become good. You take bad things from your friends, you become bad. Same policy. This is called as garbage in, garbage out. Imagine the data set to be your mind or something like that. You need to keep it clean, right? You need to take the best things out of people. Try to improve yourself every day. The same way, you need to improve the data quality by keeping the data set clean and remove all the unnecessary, confusing information. Right? So clean data leads to better prediction. Your machine learning model works better if your data is clean. So now I'm coming into the concluding part of this session. What are the things? This is a summary of what we have seen so far. Clustering of data for unsupervised learning. What we do is that we pick up all the points, we put it in red, blue, green colors, and this is called as clustering. That red is a cluster, green is a cluster, blue is a cluster, and so on. Decision trees, yes, no, yes, no, yes, no, yes, no, yes, no. You come into a conclusion. You have nodes and branches, and we have different metrics to find out whether things work out or not. Say you're going to a movie, whether you can reach the theater in time or not. One question. Second question, you have exam or not. Third question, you have fever or not. You have fourth question, you have something like that. So you have yes or no's, and all these things create different branches. And we come into a different kind of conclusion. Naive-Bayes, supervised algorithms where you have some information about the data, and we have, for example, you keep these points in mind whenever you write the answers or whenever you learn this. Whenever you think of naive-Bayes, think of email and spam, right? So that it is easy for you to remember. Your brain gets linked to that. You need to find out. You are getting a new email. You want to find out whether this email can be a spam or not, right? You have a set of emails which is spam. You have a set of emails which has free in it. You have a set of emails which has win or some other word in it. So the probability of a thing that is spam, given that you have free in it, you know that probability of a thing being spam, you have win in it. So you need to calculate the probability of an email being spam, given that it is whether free or win. Right? This is an example. Conditional probability. That means you already know an event has occurred. You already know that it has free in it. You need to come into a conclusion whether an email that has the word free in it can be a spam or not. This is your question. This is the thing that you need to answer, or your system needs to answer. Okay, so we will be finding out the probability that an email is spam given that it has the word free in it. Because you are given the message. You need to check whether you have free in it. That's already known to you. But the thing that is not known to you is that whether this is a spam or not. Is that clear? All of you? A priori, we have discussed. You have discussed what is a feature. Feature, I mean, association rules like, okay, suppose you buy one thing, now you are prompted to buy the next thing, which is very similar to that. That's an association between two products. You buy parota, you are prompted to buy, say for example, chicken. I'm not sure about it, but I'm giving you an example. So this is a good combination, right? One with the other. So this is association. This is what is meant by association. Okay. You have idli, you have a combination vada. Most probably when you buy idli, you are prompted to buy vada also. That's, that's a general, okay. Then we have understood what is exploratory data analysis. What are the objectives of exploratory data analysis? the challenges that is being faced, data preparation, how to handle missing values, standardization, and integration. So these are a set of few questions. I wish you write these answers for these questions. Keep yourself ready. Keep yourself prepared for a sudden surprise test. You can expect a surprise test from me at any time. Okay? So I want all of you to keep yourself prepared for a surprise test. Whenever I don't have enough time for conducting lecture classes, sometimes I will come out with a new idea of giving you all a surprise test. So I want you to keep yourself prepared. And these are some sample questions that I would like to give you so that the answers you should use your brain and write down. You can write it down in your own words. You can try to give an explanation to whatever you have understood. So with this, I believe that certain questions, very interesting. Why naive base is called as naive? What is meant by naive? I'm not going to answer these questions today. I prefer that you learn and you give me some inputs on that. I'm happy to accept all kinds of inputs from your side. So before I sign off from you, I would first like to thank you all for a great, wonderful cooperation, listening to me very patiently, obeying me for all. Whether you agree with me or not, you are really cooperative. I really thank you for attending this class, and I'm open to discussions and we can have some kind of interaction now. You can ask me any questions you would like. No questions. No questions. I can presume that all of you are bright students, all of you have understood everything. Or the other way around. Nobody has understood anything. Still, there won't be any questions. I am open to feedbacks. I am open to criticism. If you don't like me, you can tell me this is not good. You are being cruel, rough, whatever it is. I am open to all your queries. Please come out with questions.